In this video, we add the last transformation to our basic graphs. That is the horizontal shift. We're going to move the graph left or right. This seems like a pretty easy concept, but it can get kind of tricky. Let me show you what I mean. Let's look at y equals cosine of theta minus 60. Okay, and as you recall from our work with transformations earlier in the year, that this means to shift the entire graph 60 degrees to the right. All right, so you're probably thinking to yourself, well, I know here's the cosine graph, and if I shift it 60 degrees to the right, how difficult is that? And you're right, the basic shape of it is not a very difficult concept. But here's what's tricky, is that we have to rescale this x-axis. We've got to talk about what shifting it to the right 60 does to those key points on the x-axis. So let's go ahead and do this one. We'll graph it by itself. 60 to the right means to start at 60 degrees. Where the basic cycle ends will no longer be at 360, it will be at 360 later. And so what that means is that this is going to travel one cycle from 60 degrees to 420. I hope that makes sense to you, that if we start 60 degrees to the right of 0, we should also end 60 degrees to the right of 360. Perfect. So then we go ahead and let's see, we're going to divide this axis up and draw the basic shape. That's easy enough, but now we've got to find these intermediate points, these key points here. So there are two ways to do it. The first way involves midpoints. It's my personal favorite, but maybe not for you. I like to find midpoints. To find the middle of this graph, I add 60 and 420 together. I get 480, and then I divide by 2. So this key point is 240. Then to find this, I add 60 and 240 and divide by 2. And to find this key point, I add 240 and 420 to divide by 2, and I get 330. All right, still travel to 1 and down to -1. Okay, so that's not too bad. It does add a little bit of a challenge to it, but I think you'll be up to the challenge. Let's talk about what happens when the graph is shifted to the left. So let's go ahead and look at y equals the sine of theta plus 100. And we remember from our transformations that this means we do the opposite when it is grouped in with that x value, that theta value. So this time we're going to start 100 degrees to the left. And so for the first time ever, we're going to use the left side for one of these cycles, right? If we start at 100 to the left, I hope it makes sense to you that we won't end at 360, we'll actually end at 260. All right, how did I get that? I simply added 360 to my starting point. All right, so just like before, we need to find the midpoint. Oh, and up there I said there were two ways to do it. So that's okay. I'll go ahead and do the two ways here. First, I'll do the midpoint method, and then I'll show you the other method. So halfway between -100 and 260, I add them together. I get 160 divided by 2 is 80. When I add 80 and -100 together, divide by 2, I get -10. And then when I add 80 and 260 together, divide by 2, I get 170. And then here's the basic sine curve. All right, so the second method involves taking the period of the function and dividing by 4 to find out how far you travel each of the quarter parts to the cycle. So in this case, 360 divided by 4 is 90, right? And so I start at -100 and I add 90 and I get to -10, and then I add 90 and I get to 80, I add 90 and I add 90. Both of these methods work. Use the one that makes the most sense to you. Great. Okay, so we're going to finish up now, and I'm going to do one last problem, and it's going to have all 4 of the transformations, and this is what we'll do in class. We'll do a lot of practice. So let's say I'm asking you to graph this transformed sinusoid. All right, so we've got 4 transformations. Just as a quick review, let's go over this. This is the new midline. It is the vertical shift, and what it means to do is just to move the entire graph up 2. This is the amplitude, and what this does is it makes a vertical stretch, and we are actually stretching the y values, so they're 5 times as high. The 3 is the number of cycles in 360, and so 360 divided by 3 gives me 120, and so 120 is the period of this function. And then the last number, the 90 degrees, means to start 90 degrees to the right. This is my horizontal shift, and this back here is my horizontal scale. All right, we've been working on these for a couple of days. I'm hoping you feel really comfortable for that. All right, so here we go. In order, and the order we do is we do the 2, the 5, we skip over the 3, we go to the 90 next, and then we take care of the period last. All right, so I'm going to start out, and I have a way, we've been doing this in class, that instead of adding a new line for the midline, I'm just going to say that this that used to be the x-axis is now y equals 2. From 2, I'm going to go up to 7, because 2 plus 5 is 7, and I'm going to go down to negative 3. I'm going to skip over the 3 for right now, and I'm going to start 90 degrees to the right. Okay. Now I need to find out where I end, and so now I'm going to go back and look at this 120, and I'm going to add 120 to 90 and get 210. And this means that I'm going to have one cycle of the sine curve between 90 and 210. All right, so here goes the midpoints. 90 and 210 divided by 2 is 150. 150 and 90 divided by 2 is 120, and 150 and 210 divided by 2 is 180. Okay. Second method would be to say if the period is 120, that means that every time I move a quarter of the way through, I add 30, and we can do that to check. 90 plus 30, 120 plus 30, you get the idea. Okay, last thing I have to do is just put in those values. It's the sine, so it starts on the midline, travels up, goes back to the midline, and then completes a cycle. And so you have just graphed one cycle of a fully transformed sinusoidal function. Nice job. See you in class.